of the easy, and maybe 2 examples, also 2 questions of the hard. It's obvious that this example is hard because the base is very weird, 0.3, 1.7. Entonces yo apply logarithm. In this case, in my paper, I apply natural. And one more time, you apply the property 7, que allow us to put the exponent in the front. In this case, it's a binomial. Entonces, si es a binomial, I put inside the parentheses, no? Because this is multiplication by logarithm of 0.3. Like y here, 2x minus 1 times logarithm of 1.7. Okay, super. Now, I apply distributive property because in my mind, this working like a one number. It's a weird number, I know, but it's a number, like a 2, like a 4. And you multiply this times this and this times this in order to remove the parentheses. So we have 1 times something is something, plus x times something is x times something, equal. On the right hand side, 2x times logarithm of 1.7, 2x times logarithm of 1.7 minus logarithm of 1.7. So what is my goal? My goal is solve for x. So I propose you, it's a linear equation in this moment. Move the term that contains x to the one side, the term that do not contain x to the other side, and we combine later for factorization. So, for example, the strategy I applied was this stay in the left. This no. I move this like a, well, this stay also 2x, ln 1.7. But this guy is bring to the right hand side like a minus x, natural logarithm of 0.3. And this guy moved to the left like a positive, ln 1.7. Super. Now I can see that x is a common factor, I factor out. So we have a logarithm of 0.3 plus logarithm of 1.7. X is common factor, we have 2 times ln 1.7 minus ln 0.3. Entonces you divide both sides. You divide both sides by this factor. Okay, don't want to copy again, no? So inside the box, using your imagination, I copy this. But here I want to copy. I want to copy is 2 ln 1.7 minus ln 0.3. Okay, almost we finished. Almost we finished. Therefore, wow, this is another class. The erase is too hard in this. Okay, I try. Wow. Okay. Now, logarithm 0.3 plus logarithm 1.7 division 2 times logarithm 1.7 minus logarithm 0.3. This is the answer. This is x value. However, when you want to put in the calculator, nobody put in that way because it's confusing. Maybe much better is condensing. Remember the property number 5, we apply number 5 property here, because when you have two logarithm addition plus, it's multiplication. So you condense in only one logarithm of, and you put in the calculator multiplication 0.3, 0.3 times 1.7 is 0.51. Where come from 0.51 was the multiplication 0.3 times 1.7, no? You condense it, two logarithms and only one. And the bottom is exactly the same, but you're using the property 6. Why property 6? Because it's minus, because it's division. And property 7 also, because we have factor here that we can convert. Entonces, logaritmo, you condense in only one. Basically, 1.7 squared So these two go to the exponent place divided by 0.3. Of course, I put in the calculator automatically 1.7 squared. Okay, you put in the calculator. So far, the answer is, let me see. Wow. The answer is x is equal. In the top, logarithm 0.51. In the bottom, 1.7 squared. I put in the calculator. Divided by 0.3 is logarithm of 9. 9.63. 63 repeated. Now, this is a crucial moment. Okay, put this in the calculator. Come on, guys, help me. Remember the idea is, this is the display. Suppose that this is the display of the calculator. You type in LM. Wow. You type in LM. Automatically, the calculator put the first parenthesis. You put 0.51. Close the parenthesis. I put the top part, division now, division. 0.51, division. Close the parenthesis, important, close the parenthesis. Division now, and the bottom is ln again, pero 9 point something, 9.63. Close the parenthesis, press enter. I'm waiting for you. What is the answer? Come on, guys, working. What is the answer? What is the answer you see in the display? You know or you don't know? Guys, I need to teach you how you use the calculator to compute the value. Hey, putting off the microphone. Putting off the microphone. Carajo. Technique 1, 2, 3. Putting off the microphone. Point 29. Yeah, you are right. Point 29. Remember, I copy the answer completely. I copy the answer like that. I copy the answer is negative, no? It's negative. Negative 0.2972975. What's going on? Noise. Miss Cat Pin 1, 2, 3. Putting off the microphone, please. You are not there, right? Mute. Okay, sorry. Super. I copy the answer exactly the same I saw in the display of the calculator, no? Okay, 75, no, 75, no. 0.2972, 72, 97, 69. Wow, too much digit. No. Suppose that we need to round to the near 4 decimal place. 1, 2, 3, 4. Okay, the next digit is 9. So you increasing this in 1. So the answer is negative 0.2973, no? Okay? Okay, any question? Do you understand very well how you put in the calculator the logarithmic of the number? Yes or no? Yes, okay. Alicia say yes, but I want to hear another opinion. Because it's important. Important now. Important.
Wait, oh, so you rounded to the nearest 10,000?
Yeah. But don't worry for this. In the test, I specification how many decimal place you need to round. Traditional is 4, but not always is 4. And the lab online maybe is round to the near 10, to the near 100, or to the near whole numbers, depending on the problem. Okay? But the rule of the random is exactly the same. Okay. So I have another problem, a little bit more complicated. Suppose this equation, 4 to the x power, minus 10 times 4 to the minus x equal 3. This is a little bit complicated. And also I have, when I finish this problem, I have one similar, pero more complicated, que es for extra credit. So es additional question in the test board. And the students that are doing good receive 10 extra points. So as you are completing the test, you have 100 plus 10 of the extra credit is 110. But not this, next. Okay? So now you face that. Complicated. But I don't like negative exponent. Nobody working with the negative exponent. So I propose multiplication the entire equation by 4 to the x. Because I know that 4 to the x times 4 to the x. Now let me copy here in one corner of the paper. 4 to the x times 4 to the x is so big as 4 to the 2x. 4 to the 2x minus 10 times something. And 4 to the minus x times 4 to the x is 4 to the 0. Because negative x and positive x together is cancelled, and the answer is 1. So just 10, nothing more. But I can erase this period because it's just 4. This is the intention. And the right hand side, no. We have 3 times 4 to the x. Do you understand this or no? Okay, good. Now, in this moment, I realize okay, we have equation that we studied here at the beginning in the test 1, in which you have one expression, que the exponent is twice another expression. So you have two expressions, okay, enclosed in blue color. But the exponent here is twice this exponent. Do you remember this kind of equation? Do you remember or you don't remember? Yes, what's the name, Natalie? You remember the name? Natalie said yes. What is the name of this equation? And what is the strategy for solving this? What is the strategy for solving this? Well, first of all, the name is quadratic in front. And the strategy is define one auxiliary variable u que is equal 4 to the x. Because you are doing that substitution, this is u squared minus 10 equal 3 times u, 3u. And you convert this exponential equation in one quadratic equation. I don't know, it's not already in standard. Let me try to write in standard u squared minus 3u minus 10 equal to 0. Ready? This is quadratic, easy elementary quadratic equation. And in this case, I suppose it's easy solving by factorization because I know the combination is 5 and 2, no? 5 and 2, 5 times 2 is 10, and somehow 5 minus 2 is 3, negative here and positive here, right? Yeah, equal to 0. Therefore, we have two linear equations. You separate into linear equations. The first solution is 5, and the second solution is negative 2, no? But I know that this is not the final answer because this is the intermediate answer, because this is the u value. Yeah, I need the x value. But don't worry, because in that moment, I using this value, plugging in here, and solve for x, okay? Let's do it quickly. Okay. I split the paper, remember, in two pieces. For u5, entonces 4 to the x equals 5. It's my first equation. And my second equation is 4 to the x equals minus 2. In this moment, I need to solve in two exponential equations. The first one is easy. I apply logarithm on both sides. I apply natural logarithm of 4x equal natural logarithm of 5. Apply the property number 7, and this exponent go to the front. X times ln of 4 is equal to ln of phi divided by ln for both sides. X is equal ln of phi divided by ln. Now I need the decimal approximation for this answer. Please help me put in the calculator, in your own calculator. Come on, everyone working. Put in the calculator. Natural logarithm of 5 divided by natural logarithm of 4. Remember, we can use a natural or we can use a common. But some students can prefer doing that way. The answer doesn't change. It's the same. Come on. 1.60. Very well. Suppose they want 4 decimal place. So 1.16009, no? Something like that. See, they want 4 decimal. Okay, super. This is my first solution. I go now to the second solution, que es negative 2. Look at what happened here. Okay, you can realize que exponential never is negative. You remember the graph of the exponential? It look like that. This is exponential. Any exponential look like that, always. And we have asymptote here. And negative 2, I suppose, negative 1, negative 2. Never they are connection. They are never are intersect. Okay, so it's obvious that we have no solution. But suppose that you don't remember anything about the graph of the exponential. And you try to do exactly the same of this. And you have ln for 2x is equal ln of negative 2. And you see mistake down here because logarithms do not accept negative numbers. It's completely out of the domain. If you try to put in a calculator, this logarithm, guys. Natural logarithm negative 2. Let's see what are the meshes and the display of this. ln negative 2. Boom. What are the meshes? Come on, guys, follow me. Working. Today is active day. Everyone working with the calculator. At least in my calculator say these meshes. Domain, error. Okay, the interpretation is que it's completely outside. Because you know the graph of the logarithm is look like that. Yeah, I asked you negative 2. In negative 2 we have no graph. And positive 2, yes. 1, 2. This value. But in negative 2, it's complete out of the domain. That means that this equation have no solution. It's a stupid equation, right? And the only solution that we have in this problem is this. Any question? Okay, extra credit now. Extra credit, you turn into me with the test, no? The test day. Okay, suppose que es December 10. The test for us due December 10. This is my plan, no? I confirm in detail in your moment, no? Extra credit. Extra credit represent 10 extra points. You solve this equation. 1 to the x plus 2 to the x equal 4 to the x. Your answer, 2 4 decimal place. Okay, this is attached to the test 4. Do you copy? Okay, very good. Well, so let's change a little bit now. We study another thing similar, que es logarithmic equation. Wow, this is a little bit hard. Logarithmic equation. Logarithmic equation. Okay, no exponential, logarithmic. Es equation que contiene code logarithmic. Okay, let me start for the first. And the procedure is always the same. Logarithm base 3 of x plus logarithm base 3 of x minus 24 equal 4. Okay, copy that. This is my example 1. Okay, the strategy is always the same. You have several logarithms, 1, 2, 3, 4. In this case, we have only 2, and you condensing in only 1. In this case, you apply the property number 5. Why? Because it's plus. Because logarithm, you condense it in only 1, get the multiplication x times x minus 24. You copy x times x minus 24. Don't forget the bracket, or the parenthesis extra, to enclose everything in the argument of the logarithmic function. Something like that. So you condensing, this is my first step. You condensing 2, 3, the amount of logarithms we have in the equation, and only 1. And the right-hand side and the left-hand side. I prefer move any logarithm to the left. Okay, condensing in only 1 using the corresponding property. In this case, was property number 5 because it's plus, but if it's minus, it's property number 6, no? Okay, now this is the crucial moment. This is the most important moment now. You convert to exponential statement. So this arrow, you put the arrow, and we are doing conversion. This is logarithmic statement, and you convert to exponential statement, exponential. You write exactly the same in the test. I understand very well the action. Okay, now, in order to convert to exponential statement, you ask by yourself, what is the base? The base is 3. Look at that. This is a small number representing the base. And this is a small number you copy big, because now it's the base. And the exponential statement. The exponent is 4, que es the answer for the logarithm, always. 4 is the exponent. This 4 is this. Copy. S equal the rest. It's the result, is x times x minus 24. Okay, and now it's easy because this new equation is no logarithmic equation, is no exponential equation. No, because 3 to the 4 power is 3 times 3. So 3 times 3 times 3 times 3. You put in the calculator, it's 81, no? 3 times 3 is 9. 3 times 3 is 9 again, and 9 times 9 is 81. So basically, in this moment, we have this equation that is 81 is equal. Why no? You apply distribute the property here. X squared minus 24x. Wow, this is a quadratic equation. It's obvious it's a quadratic equation, right? Let me try to write in standard form. So in standard elegant form is x squared minus 24x minus 81 equal to 0. The right hand side 0. Entonces I pay my attention only in this quadratic equation. In this case, by factoring no good. Much better apply the quadratic formula. Quadratic formula minus b plus or minus square root b squared minus 4ac divided by 2. And you determine who is A is 1, B is negative 24, and C is negative 81. Plugging in into the formula. This is 24 double minus become positive. This is 24 plus or minus square root negative 24 squared minus 4 times 1 gets A, C, negative 81. Divided by 2 times 1. Just 2. I put in my calculator, 24 squared. Or negative 24. It doesn't matter if it's positive or negative because when this square becomes positive. The 24 squared is 576. Be careful with the sign. We have minus here of the formula. And we have minus here of the 81, okay, negative 81. Double negative become positive. So it's 81 times 4 is 324. And you adding, in this case, plus. Ooh, it's 900. And square root 900 is 30. Okay, super. So we have 24 plus or minus 30 divided by 2. And you separate in two pieces. 24 plus 30 over 2. And 24 minus 30 over 2. This is 54. Divided by 2 is 27. This is my first solution. And this is negative 6. 24 minus 30 divided by 2 is negative 3. Okay, and this is the most important moment now, guys. Remember, and when we solving exponential equation, you never need to check it. Because what's the reason? The reason is because the exponential function is nice. Exponential function, the domain is all real number. So exponential function accept any number. However, logarithmic function, no. Logarithmic function is very, very picky and accept only positive number. Negative number, no. And 0, no. Because logarithm of 0 is undefined and logarithm of the negative number is undefined. So I have a doubt about this solution. So I need to check it, mandatory, checking both, just in case I want to check in both. So I'm plugging in 27 and negative 3 into the original equation. The checking part is super important when you are solving logarithmic equation, okay? Mandatory, check it. Let's check in 27, checking for x equal 27 into the original equation. Okay, entonces es replace 27 for x. Entonces my equation is logarithm base 3 of 27 plus logarithm base 3 again of 27, que es x, minus 24, should be claim that statement 4. I need to prove somehow. Well, it's easy because logarithm base 3 of 27 plus 27 minus 3, logarithm base 3 of 3. Should be 4. How we prove that? How we prove that? Well, I suppose there are many ways to do that. Okay, what is the logarithm base 3 of 27? What is the answer? What is the answer for this one? 3. And it says this is 3. Because, well, okay, there are many ways. Remember, intuitive idea by hand or calculator. So in the calculator, remember, we have a standard logarithm. And then you convert this using the chain of base formula like that. ln or log, whatever you want, of 27 divided by log of 3. And when you put in the calculator, your answer is 3. Another way is intuition, common sense. 3 to the, what exponent is necessary to raise 3 in order to get 27? It's obvious 3, no? Because 27 is 3 to the 3. And what about logarithm base 3 of 3? When the number is the same, they are perfect coincidence. 3 here and 3 here. What is that? What is logarithm base 3 of 3? Come on, help me.
Say again, please, Professor.
My question is, what is the value of this expression? 1.
Yeah.
1. Natalie say 1. Remember, when there's logarithm of a, when the number in the inside the argument, it's inside the parenthesis, is equal to the base, the answer is always 1. The answer is 1, and 3 plus 1 is 4, right? This is one point of view. Another point of view is suppose to do not complicate this. In order to compute separately, no, we condense it. Logarithm en one logarithm, you apply the property number 5 one more time. Entonces, logarithm base 3 of 27 multiplied by 3 is 81. Oh, you know that. You know that 3 to the 4 power is 81. Remember, in the middle of the process, you apply this idea. The confirmation is okay. Confirmation. The answer, okay, the answer that we are checking, que es 27, is good. 27 is super good. Check mark. But -3 is a bad. Why is it bad? Because you try to check it for -3, logarithm base 3 of -3. Wow, it's impossible. It's completely out the domain. Domain error. So what is the final answer in this problem? Well, okay, the error. And the final answer is just 27. So the solution for this equation is just solution set 27. We have only one solution. The problem is, okay, see, I summarize everything is you have several logarithms in the equation. You condense it in only one. After that, you transform it, convert logarithm statement to exponential. And magically happen that my new equation is a quadratic equation or linear equation. Let's see in the next example, get linear equation. And you apply your own algebra. You determine the value, but the value you need to mandatory checking into the original. Because remember, we are working with the picky function, que es logarithmic function, que not always is solution. Okay, this is the idea. Any question? No? No? Come on, guys. What happened today? Are you cold? What is the temperature in your home? Is 58, no? Okay, example 2. Are you freezing? No, okay. Example 2. Logarithmic equation we are doing. Logarithm base 2 of 3x minus 2 minus logarithm base 2 of x minus 5 equal 4. Okay, this is my second logarithmic equation. So in my second logarithmic equation, remember the strategy, we condensing. We have two logarithms, but we condensing only one. But in this case, this is minus, you apply the property number 6. Entonces, division es logaritmo base 2 of 3x minus 2 in the top and x minus 5 in the bottom, no? Don't forget the parenthesis here to enclose everything inside the argument of this function. Should be equal 4. Okay, so we condensing 2 logarithms, 3 logarithms, in this case 2, and only 1. And now this is a crucial moment in which you convert to exponential statement. Okay, entonces I ask by myself, what's the base in this logarithm? It's 2. This is small 2 is important. You put now big 2. What is the exponent? The exponent is the answer of the logarithm always, is 4. Remember, this is the interpretation. The interpretation of the logarithm is the exponent. Give me the exponent necessary to raise the base in order to get this. And the rest is 3 minus 2 over x minus 5. No more logarithm. And 2 to the 4 power is 2 times 2 times 2 times 2, 4 times is 16. So 16 is equal to 3x minus 2 over x minus 5. This is a linear equation. You apply cross multiplication maybe, like that. Says 16 times x minus 5 is equal 1 times 3x minus 2. And you know 1 is invisible, multiplier. Now I apply distributive property because I want to remove this parenthesis 16x minus 80 is equal to 3x minus 2. Okay, I propose you 16 stay, I move 3x to the left, and minus 2 stay, and plus 80. Okay, now combine like term, 13. In that case, 78 divided by 13 both sides. That's the 6. And just in case, I need to check it. In this case, we have only one answer. The reason is we have only one answer is because when you are doing the transformation, we have linear equation. Linear equation normally have only one solution. Si es quadratic, no. The quadratic, you have two solutions. Let me try to check it. So the checking is easy. Just plugging in 6 into the original equation. Logarithm base 2 of something. 3 times 6 minus 2. Minus logarithm base 2 of 6 minus 5. Should be 4. I claim this. I need to prove it's true. See, I prove it's not true, it's false. So 6 doesn't work. Okay, let me try. 3 times 6, 18. 18. So basically, logarithm base 2 of 16 minus logarithm base 2 of 6 minus 5 is 1. It's equal 4. Help me, guys, how you prove that this is true or false? What is the logarithm base 2 of 16? Remember, hand or calculator?
4.
By hand, a 4. Any? 4, Natalie. Natalie take a 4. This guy a 4. And what about this guy? Logarithm base 2 of 1. 0. Logarithm of 1 is always 0. And 4 minus 0 is 4. Hey, this statement is true. And the solution is perfect. And the solution set for this equation is 6. End the story. Any question? The mandatory checking in the logarithm. In the exponential, no. In the logarithm, yes. Okay. One more logarithm equation. And after that, we go to the application. Word problem of the application, but easy. Okay. Easy. I promise que Friday, I will send the review package for the test 4. Okay? Okay. Example 3, logarithm equation. Okay. Is logarithmic base 14. Normally, this equation involves non-standard logarithm. 14, 3. But I don't care because I convert to a standard if you want to compute. Is equal 1 minus logarithm base 14 of x. This is our example 3. Example 3. Entonces, in the example 3, the only new thing you can see is que the logarithm is placed in different sides, no? One logarithm on the left, one logarithm on the right, but I don't care. I move. Okay, the first thing is move to the same side. For example, I make a decision to move this state. I move to the left. Equal. Okay, ready. Now it's ready to condensing. And you apply one more time the property 5 because it's plus and multiplication. So you condense in only one logarithm and inside is the multiplication x times x plus 5. And everything is expression inside the argument of the logarithm equal 1. Okay. Listen, look. The first thing I did was try to group in any logarithm to one side. And in the previous example, it's already in the same side. But in this case, no. Okay, because I move, accommodation, now condensing only one, ready to have only one logarithm in this moment. Now I convert to exponential statement. The base is obvious que 14, I copy big 14. The exponent is obvious que 1, and 1, you know, it's invisible exponent. Equal the rest que es x plus 5. Wow, super easy equation. I suppose que es quadratic equation because when you apply distributive property here, we have x squared plus 5x. Okay? And when you see 2, exponent 2 is quadratic. Let me put in a standard form. Standard form is x squared plus 5x minus 14 equal to 0. This is my equation I need to solve it using the quadratic formula or factorization. I suppose the factorization is easy in that case, no? Yeah, because the combination is obvious 7 and 2, no? 7 and 2 7 times 2, 14. 7 minus 2 is 5. Positive 7 and negative 2. So one solution is x plus 7 equal to 0. That means x is equal to minus 7. This is not good. Remember, when it's negative, value is completely out of the domain of the logarithmic function. And x minus 2 is equal to 0. X equal to 2. Okay? So in this moment, I need to check it. Checking this and checking that. Let's do it. I know very well that negative 7 doesn't work. No solution. Because when you try to plug in negative 7 here, automatically say no solution. So let me try to do x equal to 2. Yes, I copy the original. Logarithm base 14 of 2 plus 5. Just replace x for 2. In the right hand side, I claim that 1 minus logarithm base 14 of 2. Okay, I need to prove this. It's true or false. Well, 2 plus 5 is 7. You know that. Entonces, logaritmo base 14 of 7 should be equal 1 minus logarithm base 14 of 2. To prove that, I suppose that the easy way is I move this logarithm again, similar to the beginning. I move to the other side, logarithm base 14 of 2 of 7, sorry, plus logarithm base 14 of 2. Should be 1. And you condense sin. Again, using the property number 5. Entonces, logaritmo base 14 of the multiplication. Multiplication is 7 times 2, 14. Wow. And when you know very well, the property number 2 we study is when the base and the argument is the same as 1. Entonces, true, super true. And 2 is the only solution that we have in this equation. Guys, do you understand very well or no? Yes or no? Okay. Inaya say yes, I understand. Opinion, guys. Clear, super clear, confusing? Yeah? Okay.
Yes.
Eso, bueno. Guys, remember, when you are doing the homework, any question that you have, you send me the picture. Pero Ernie, send me one good picture, no bad picture. Okay? Okay, I don't see. I try. I don't see. Entonces maybe I make a mistake, no? When I solving the problem. Because I don't see very well. You take a picture and you send me back. I solve the problem and the homework part. Okay? This is the way to study. Another class, there are more students can send me questions. I am available anytime for you. Well, let's go to application now. Application, the real life, about exponential, about the logarithmic equations. The first application is a compound interest. Compound interest. Basically, the idea of the compound interest is investment. You work too hard, you earn your money, and you save your money in the bank account. But my recommendation is create, after when you have not a lot of money, but some money, you invest the money. So you open, for example, one CD account, or you buy another financial tools, like a bonus, a stock market. But investment is super important. Investment, you deposit the money in one CD account or safe account, and your money, so you don't withdraw the money increasing. And I want to illustrate the power of the compound interest, how the money increasing too fast, because it's like an exponential, similar to exponential. Okay, basically when you open an account, the bank say, no, we have your account have one annual percent rate. Okay, this is the interest rate. So I call little r the annual percent rate, que es the rate in which the money increasing, no? 5% or 3% or 4%, 7%. Entonces, let me try to explain the idea behind the compound interest. Look, this is the cash flow line, que es a tool to help me to understand the mathematics behind the compound interest. Okay, suppose que now at t equals 0 is now. You go to the bank and open the account and you deposit one money. And this money is P. P represent present value. P represent present value. Present value. Okay? Y I suppose, to simplify the thing, que this segment line represent 1 year. After the 1 year, what is the money that you have? Si you don't withdraw the money. Bueno, the interest rate increasing. Entonces, the interest is R times P. This is the interest. So I, interest, capital I, is RP. Bueno, RPT, pero T is 1. Because I suppose that this is T equal 1. 1 what? 1 year. So this is the interest que is addition with the initial money. So you have in this moment RP plus P. Two money. The initial money, you never withdraw, the interest you earn together is RP plus P. You factorization P, we have 1 plus R. Let's see what happened in the second year. T equal to year. Okay, this is the flow, cash flow in that direction. Entonces, the money you have in this moment is, well, the interest earner is this money, so R, again, similar to this, R time, pero no P, sino es P, 1 plus R is the money that you have in the 1 years, okay? Plus, again, this money is P, 1 plus R. When you multiplication by R, the money that you have in this moment is similar to this. This is the money you have, your multiplication by R, you compute the interest. This is the interest plus the current money that we have, is this. This is easy to understand, is U factorization P, P1 plus R. We have R plus 1. Look, U factorization P1 plus R, P1 plus R, factor out, stay R, get this R, this R is this R. Wow, entonces P1 plus R times SL, que es square. Entonces the formula es clear. Suppose for to T equal M. No M, T, in general, T. For T, the formula is future value, capital IA is future value, the money you have in the future. The future value is equal present value, 1 plus R raised to the T. And what is T? T represents the years. 1 year, the exponent is 1. 2 years, the exponent is 2. Look at that. 3 years, the exponent is 3. T year, the exponent is T. Okay? This is the idea for the compound interest. Exponential, somehow it's exponential. Okay, now let me try to refine a little bit that formula, because sometimes the bank offer different compounding. Compounding is let me complicate a little bit the formula with the new concept is compounding. Compounding is, for example, is denoted by M. When the N is 1, it is annually. What means that? Que your money increasing 1 in 1 year increasing 1 time. Pero suppose que the bank say, no. Your account is semi-annually. What mean that? That means that your money in 1 year increasing 2 times. So suppose 1 year, but your account now is semi-annually. The money increasing 1 step 6 months and 1 step 6 months. So n is equal to. So basically compounding is a number. Maybe it's 1, it's 2, it's quarterly. Okay, divide the year in different new period. For example, n equal 4 is quarterly. N equal 12 es obvio que es monthly. N equal 52 is the amount of weekly we have in 1 year, weekly. And n equal 365 is daily. Okay. This is fixed by the bank. Your account is quarterly, or your account is normally the retirement account in Miami-Dade call it is quarterly. So my money increasing 4 times in 1 year. Okay. So I refine the formula. This is not this formula. The formula is more sophisticated like that. Look, include M compounding is future value is equal present value 1 plus R over N, because the interest rate, this rate is annual. You have different periods inside 1 year, you divide the interest by N. And multiplication, the time, and T. This is my final formula. Okay, let me explain in detail. Look, little r is annual percent rate. So you have different period inside the year, you divide the interest divided by N. But you increasing the number of periods. And so you suppose que es annual, que es 1 year T is equal the years. But suppose que we have, I don't know, 5 years. 1, 2, 3, 4, 5 years. But the account is quarterly. And quarterly is you divide each year by 4. Bam, bam, bam. So this is 1 year. That's a 4. A 4. But 4 multiplication by 5 years is 20. Actually, my stairs, my money increasing like that. Okay? And the stairs have 20 steps. And where come from 20? Was the multiplication? N T. T represent the year, N represent our example that I illustrate you now is quarterly. Do you understand the idea for the formula? Okay, you don't need to memorize this stupid formula. Okay, you just using the formula. Okay, let me copy the collection of the most important formula that we are using here. This is the formula to find, well, this is the formula, the compound interest. And we're using in different situations and different problems because sometimes ask you the future value, but sometimes no. Sometimes you need to solve over time because I want to find how many years I need to wait in my account to expect different money. No? Let me copy the first example of the application. But I need help, guys. Example 1 of the application. Okay. If $10,000 is invested in an account at 3% APR. Compound quarterly. The question is how much will be in the account. Oh, in 5 years. 5 years. Okay, the supposition, of course, if no money. Is withdraw. Okay. Okay, this is a typical problem you can see in the test. Use identification in the formula. Data that we have in the problem. 10,000. Who is 10,000 in my formula? Who is 10,000 in my formula? P, present value. It's the money we have now. Very well. One more thing. Well, the account is 3%. This is the annual percent rate, is R. But R is 3%. Okay, I understand very well. However, in the formula, you never write in percentage. No. You convert to decimal. You divide by 100, 0.3. Okay, 0.3. Okay, super. Now, okay, important. APR convert to decimal, divided by 100. Compounded quarterly, N is equal 4, you know. So my money increases in 1 year 4 times. So the retirement account in Miami-Dade College send me each 3 months the statement of my money, okay? Now, you say, what is the thing I try to find? What is the issue? T, F5 year. T is 5 years. Sorry, T is 5 years. 5 years. I need to find future value, no? Future value, I don't know, because I want to know this money I deposit today, how many money represent in 5 years. And you apply the formula. No? The formula is present value, 1 plus R, and 80. Okay, future value is equal $10,000. 1 plus 0.03 divided 4, because N is 4. And everything raised to the multiplication NT. N is 4, T is 5, 20. The exponent is 20. Where I come from this 20? Multiplication 4 and 5. And this is the thing I try to put in the calculator. Please help me with the calculator. Remember, we're using the calculator not only in the logarithmics, in the exponential. So you put in the calculator like that. Let me try my own calculator. Okay, you try your own calculator also. This is the display of the calculator. You put it in the display, 10,000. Multiplication, period. Open parenthesis. 10,000. Multiplication, open parenthesis. Inside the parenthesis, I put 1 plus 0.03. Division 4. Close the parenthesis. 0.03 division 4, close the parenthesis. Now the power, you're using that symbol. Because most of the calculator have that symbol. Power 20. Boom. Yeah, I can get the answer. Power 20. Let me know your answer, guys. I have my answer in my own calculator, but I want to know your own answer. Come on. And remember, this is the currency. It's the money. You say, very well. This is the answer, Natalie. Entonces, this is, you need to be aware that this is the currency. It's the money. Therefore, the round is a specification to the near cent, so to decimal place. It's 11. The answer is 11,611 and 84 cents. Is the answer. This is the future value. This is the money that you have when you deposit $10,000 in one account. One account can have this characteristic, 0.3% APR, compounding quarterly during 5 years. Any question, guys? Do you understand very well this or no? Come on, question. I need to hear question.
Yes, Professor.
Okay. Okay. I want to complicate a little bit now. Another problem of the same formula, but a little bit more complicated. Okay. Okay. Super. Okay. Example 2. Example 2 is different because example 2 of the compound interest is okay. $2,300 is invested at, say, 6.5% interest. Okay, this quantity always is classical, expressed in percentage, and this is annual percent rate. No specification, but you need to understand default. Comma. And it's a compound annually. Entonces, si es annually, entonces N es 1. You know. So the question is how many years? How many years will it take? It is the money it take to accumulate $4,000 or more in that account. Okay. Of course, question mark. Okay, let me try to understand the problem and let's set up here the data. Okay, who is $2,300? Who is that? Who is present value, future value? Present value, very good. Present value is this. Es obvio que R, interest rate, es 0.065, expressed in decimal, ¿no? Divided by 100. And one more information. Compound is 1. Compounding is 1. Nice. It's easy. And this number is a future, no? It's a future.
T is 1.
Suppose you want to buy something and you have no money. You have only 2,300. You deposit in the bank account. You're waiting. I don't know how many years. Entonces, in the year I try to find, you get $4,000. O sea, future value of 4,000. So what is my question? My question is T, no?
T,
que represent how many years? Okay, no problema. I copy my famous formula. Future value is equal, parentheses, 1 plus R over N. I forgot P here. P right to the NT. This is my formula. Plugging in into the formula. Plugging in. And the formula A is 4,000. A is equal 2,300. Parentheses. 1 plus 0.065 divided by 1, because N is 1, entonces 1 is invisible. N T, N is 1, and T is the only unknown that we have in the problem. Do you understand this equation now? N is 1, it's invisible. T is the only variable in my problem, no? Yeah, I try to solve in this way. It's obvious, guys, that we have at that moment exponential equation. Okay, normally we call X, but no, in the real life we have time because it's years. Okay, now we condense it, why not? 4,000, 2,300, this is 1.065, because 1 plus something is 1.t. And we have in that moment exponential equation. More clear now. Exponential equation is obvious that this exponential equation, never we can express it using the common base. And you manipulate a little bit in order to apply logarithm, no? Okay, entonces I propose you divide both sides by 2,300. We have 1 plus 1.065t. We can cancel out 2 0. We can cancel out 2 0. And we have 40 over 23 equal 1.065 raised to the t. And you apply why not logarithm. What kind? Well, standard. You apply either natural or log, whatever you want. You apply natural. And you apply one more time the property 7. The property 7 allow me the exponent go to the front as a factor. This is natural logarithm of 40 over 23 is equal to t, and the front fly to the front, natural logarithm of 1.065. Now the time you solve for t is natural logarithm of 40 over 23 division natural logarithm of 1.065. And this is t. And this is t. Okay. And this is the moment to put in the calculator and interpretation the answer, right? Let me try how you put in the calculator like that. This is the display of the calculator. Okay, everyone doing the calculator, using your own calculator. You need to learn your own calculator. You put LM, boom, boom, open the parenthesis. So when you press LM, automatically, the calculator open the first parenthesis. You put 40 division 23, close the parenthesis. I type in the top part, division now. LN 1.065. Okay, let me try. 40 divided by 23, close the parenthesis, division now, another logarithm of 1.065, close the parenthesis, present. Boom, I get the answer. Tell me, what did you answer? Okay, Tico, the answer is 8.7874. I get exactly the same answer. Entonces, the answer say, how many years I need to wait? I need to wait in decimal year? No. In this case, using common sense, this represents 9 years. Of course, in 9 years, you have more than $4,000. But no, a little bit. So the minimum year to reach or overcome the $4,000 is 9 years. Okay? Super? Understandable? Confusing? Clear? Okay, one more example. I have another example, similar to this, in which you need to manipulate the equation in order to find the time. So a typical question is, or you try to find future value or the money, the time. You need to wait for accumulate the money. This is another example similar to the example 2. Example 3 is similar. Example 3 is John wants to buy 30,000 car. He has saved 27,000. Find the number of year each will take for is 27,000 to grow to 30,000. Add for interest rate compounded quarterly again. Compounded quarterly. Okay. Data. Let me try to understand this problem. What information is given? What information I am trying to looking for? Okay. Who is 30,000? Who is 30,000? Capital A. Very well. Who is 27? The present value, no? The money John has right now. SP. Alicia is P. 27P. Interest rate is 0.04. Compounding is quarterly. I need to find time. Okay. I go to my favorite formula. Is the value is equal to present value 1 plus R over N. Future value is 30,000. Present value 27. 1 plus R is 0.04 divided by 4, compounding is 4 period, and multiplication NT is 16, right? No, sorry, 16, no, coño. Es N que 4, but T, I have no idea. Is the time, is the year, okay, I need to wait. Okay. I can simplification a little bit this. Look, this 30 we can delete, yes or no? So the basic is 30 divided by 27. We can simplification is 10 over 9, no? Divided by 3. And here I can condense it as 0.04 divided by 4 is 0.01 plus 1 is 1.01. The 0.04 divided by 4 is 0.01 plus 1 is 140. And this is my equation. Let me copy my equation. My equation is 10 over 9 is equal, paréntesis, 1.01 raised to the 40. Ready to apply logarithm. Ln or LOG? Let's apply LOG, why not? For practice. LOG of 1.01 raised to the 40. Okay, this is the argument for the LOG. Okay, remember the property number 7, and you apply, and this exponent go to the front. So LOG 10 over 9 is equal 40 LOG of 1.01 alone. Therefore, T, que es my goal, is logarithm of 10 over 9 divided by 4 times this, because I want to express T alone, isolate T. Log 1.01 is equal to boom. Okay, and this is the time. Remember, when there's a time, when you talk about the time, you round to the near whole number, no? It have no sense to talk about decimal years. You know, it's 5 year or 6 year or 7 year or 9 year, 8 year, 10 years. You don't need to wait. You put in the calculator like that. LOG, parenthesis 10 division 9. LOG 10 division 9. Close the parenthesis. Division, be careful with the grouping symbol. Be careful with the parentheses. Division, division, division. So, and the division, and the bottom we have two guys. So you enclose in the parentheses. Because you omit the parentheses. Entonces, 10, logaritmo 10 over 9 is divided by 4, and after multiplication, this is wrong. It's wrong. Entonces, 4 times logarithm of 1.01, close the parenthesis, and close the parenthesis. You open to and close everything at the bottom. This is the order of operation. And you need to indicate, remember, this is a calculator, and the calculator is not smart. Smart is you. Okay, entonces open parenthesis for multiplication, logarithm again, 1.01, and close two parentheses. Bam, bam. Press enter and wait for the answer. Come on, Gaia, more participation. No only Natalie, Alicia, another guy. Okay, waiting for you. It's too complicated putting the calculator this? Oh no. How many years I need to wait? How many? John. I know. John. Come on, guy. Tatiana. Tigo. Natalie. Kyla. Pascual. Alicia. Shinaya. Robert. No? Are you boring? You sleeping? Wow, what the hell? Nobody doing that. One year, no, Tico. You type it wrong. I got N, but I think it's wrong. N. What about N? No N. 2.64. There's the answer. Yeah. The answer, Natalie, is 2.64. No, 64, 7, 1, 6, I don't care. Basically, it's 3 years. Guys, come on, do it again. Do it again, because you need to get that. Come on. Clear the display. And the order is clear. You press. Okay, let's do it together. You press LOG key. Aromatical LOG. Open one parenthesis. Inside you put 10 division 9 and close the parenthesis. 10 division 9 and close the parenthesis. Now division again. This line is division. The tricky part is that you need to open new parentheses to enclose everything in the bottom. Because see, you write without parentheses, the calculator working from left to right, and compute this part and division by 4, and after multiplication by this. This is wrong. Because 4 and logarithm 1.01 is in the bottom of division. So you need to indicate the calculator, okay, you perform according to this order of operation for multiplication logarithm 1.01. Okay, and this parenthesis enclose everything in the bottom. So it's 4 times LOG, otra, again, 1.01. And close the parenthesis. Close two parentheses. I get the answer. 2.64716. Yes or no? Come on, guy. Okay, Natalie. Only Natalie. Hinaya, of course. To say you, Hinaya, you know very well working with the Casio calculator, right? Cat pick. Okay, suppose I don't know, cat pick 1, 2, 3, que create noise in my classroom. You did that or no? Silent. Alicia, yes. Pascual, no? No participation. Felder, yes. Okay. Okay. One more problem, and that's it. One more. I don't know. One more. Okay. This is the formula. Let me erase the board. This is the formula for the compound interest. But we have another formula. We have another, yes, we have another. Okay, we have this future value is equal to present value, 1 plus R over N and T. And remember, we can apply this formula in different senses. So in order to find future value, in order to find time, so it's only manipulate, no? It's algebra, it's basic algebra. Okay, but the supposition behind this formula is the money increasing like this is P at T equals 0, and the money increasing like stairs. Okay? And the interval here is a compounding, no? It's maybe 1 day or 1 month, depending the compound. See you, for example, you want to study another financial problem in which you have no idea the compounding, because, for example, the typical problem, okay, for example, you have no idea how change is the stock market. The stock market change in a minute, or in second. Entonces, you have no idea, and the supposition is that the money increasing or decreasing, depending, continuous. No like stairs. No, continuous. So the formula for the compound interest is not like that. This is discrete, like stairs. But you have another formula that is future value is equal present value exponential e to the RT. And this is called a continuous. Continuous. Compound continuous. Continuous. Compound continuous. And don't worry, because the problem is specification. See, it's discrete. It says annual, semi-annually, quarterly, monthly. You understand that N is equal to one value, but the problem no specification anything. Or you suppose que es continuous, or the problem say, no, you suppose continuous compound. Okay? Let's do one more problem of the continuous compound, and that's it for today. Okay. So you have to formula, right? Discrete and continuous. Suppose this problem. This is the last one, 4. Example 4. Find the amount A, future value, no? That result from investing a principal of present P of $2,000 at annual percent rate 8%, compounding continuous. for t equals 1 years. No plural, singular, period. Okay, then present value is 2000. So the formula is, when you hear the word continuous, the formula is not the classical formula. No. The money not increasing according to this law. No, it's according to this law. Okay, super. But present value is 2000. Entonces future value is equal 2000. Okay. Y es exponential. What kind of exponential? The same exponential we studied last time, que is using E, que in the same key. Normally, any calculator have this convention. Look, any calculator have one key is LOG, one key is LN, close, very close. Above the key, we have the exponential associated with the same base, 10 to the x and e to the x. The thing is, we're using this function. And this function you select because it's the same key, using the key second. Some calculator have, and my calculator is the blue color key, another is yellow color, or another is green color. In order to select this function, you press first, second, ¿no? Entonces you press, pero entonces the exponent is RT. Who is R? 8. Pero you press in 0.08 in decimal, divided by multiplication by 1, que es 1 year, because the problem says que es 1 year, and that's it. Okay, entonces, how you put in the calculator this? Well, you put in the calculator like that. This is the display of the hour calculator. Wow. Okay. You put 2000 multiplication. Let me try my calculator and you follow me. 2000 multiplication after. And you select that function, que es exponential, when the base is E. So this is located above the key LM, but you press second, you press this key, and you can see in that moment something like that. Look, E power after, parenthesis. E power parenthesis. And you put inside 0.08. Time 1, no, because 1 is invisible. It's 0.08. Close the parenthesis and end the story. Present. Bang. Okay, I waited for you. What's the answer? How many dollars? I waiting. 16, no. No, Yesaira, $16. See, Yesaira, you have 2,000. And you invest money, you expect more money. Good. This is the answer. The answer, Natalie, say, is 2166 and 57 cents. Yeah, you're right. Okay, super. This is a future value. So the money increasing like that. Look, the money increasing, go up, not down. So $16 have no sense. This is time, this is money, this is present value. And so the supposition is when it's continuous, okay, the money increases according to the exponential. This is 1 year, 0, 1 year. This money is 2,000, and this money is bigger, no? Future value is 2166 and 57 cents. Okay, make sense or no? Okay, guys. Yes, I suppose it's too much for today. Friday we continue application, but another kind of application. Application with the biology, physics, archaeology. Okay, in which you apply exponential and logarithmic function. Okay. And I promise that Friday I will send the review packet for the test 4. Okay, we are doing during the Monday next week and Wednesday. And Wednesday, que es December 10, I will send maybe before for you. I send the test and you have time to solve in the park, okay? And that's it. The semester is over. I will send both. I will send the test 4 and the test and the final test. And you, using your imagination, if you need to take the final or no. I strongly recommend a student that fail or missing one test, of course, take the final, because the final always replace the worst test. Suppose you are missing one test, you have 0 point in this test. You can see your grade in the blackboard. So you make a decision to take the final and put together, turn into me both. Okay? So yeah, I don't see final because you make a decision and you don't need to take the final. Okay? Okay, guys?
Sure.
Question. Come on.
Can you correct the grade for me, please, on test 2 online, please? On Blackboard.
Because it's incorrect?
Yeah, he's incorrect.
Okay. Erne, no?
Yes.
Just in case, email me to remind me right now.
All right, thank you.
Okay. Any other question, guys? Let's see Friday. Friday. Everyone here.